Hello, my name is Michael Geyer and I'm a research assistant under Professor Dr. Sommer in the Laboratory of Quality Production Management and Bearing Technology at the Technical University of Applied Sciences, Würzburg-Schweinfurt. And today I would like to explain and show you how the electrical property of the impedance can be used to assess the condition of a bearing. The condition monitoring of the bearing via the measurement of the impedance is possible because of the geometric properties of the individual bearing contact and the presence of an insulating lubricant. This combination leads to an electrical behavior like that of a capacitor, where the contact areas of the roller and the raceway represent the cross-section area of a capacitor and the lubricant the dielectric material. In the presence of a separating lubrication film, as shown here, the electrical behavior can be described as an operation-dependent parallel circuit between the resistance of the mainly lubricant and the capacitance consisting of the capacitances of the inlet, outlet zone, and the Hertzian area. Changes occur, however, on metallic contact between the contact partners, where the capacitance of the rolling contact is short-circuited by the low ohmic metallic components. In order to facilitate an impedance measurement, we used the test rig here shown in the schematic, which enabled us, in combination with the impedance measuring system from HCP-Sense, tests at different rotational speeds and radial loads. In all the tests of the impedance measuring method and the bearing status, the bearing type 6005-2RSH with the lubricant MT47 was used. This test bearing, the two support bearings, as well as the mounting shaft and its connection to the electrical motor are electrically insulated to the environment. This was done to secure the measurement signal against influences of external factors and partial or complete loss of the signal. So how does this measuring system get us our impedance values? Well, the impedance is a value that is not directly measured, but is calculated through an implied alternating voltage and a corresponding alternating current. The HCP system uses the same technique and applies a high frequency but low alternating voltage at the contact points and measures the flowing current. The important part of the measurement is the insulation of the signal from the environment, like we did to secure the measurement of the test bearing. Now let's look at the measurement data of two test runs. In the initial test, an undamaged test bearing was subjected to various speed levels, gradually increasing over time. It clearly shows how this influences the value of the impedance magnitude. In the state of boundary lubrication, the mainly metallic contact in the bearing leads to a mostly low ohmic value band with occasional high ohmic peaks. In the mixed lubrication state, this behavior changes into a higher ohmic value band with high number of dips into lower ohm values. This number decreases with higher rotational speeds, however. Both changes occur because in this state a separating lubrication film begins to form and the number of contacts between the roller and raceway decreases. At higher speeds, a stable lubricating film reaches a sufficient thickness to eliminate any chance of metallic contacts. This can also be seen in the impedance magnitude signal, in which the impedance values only occupy a stable value band without dips into the lower ohm values. The second test aimed to determine the influence of the damage on the impedance value of the bearing. To do this, the impedance of the test bearing was measured at first in the undamaged condition and then with an outer ring damage. Both conditions show a stark difference in the impedance behavior. At the start of the undamaged condition, the rolling over of the high viscous lubricant leads to a sudden decrease of the lubricant thickness, and this results in the high peak of the impedance. Furthermore, it can also be seen that the temperature and therefore the viscosity influences the impedance. The increase of the temperature over time leads to the decrease of the viscosity and the film thickness, which results in the shrinking of the impedance. Near the end of the undamaged state, a stable value band was reached without dips into low ohm values, which signals a stable separating lubricating film. This changes in the damaged condition, where a high fluctuation of impedance values from the mainly low ohmic values and up to several kilo ohm values replaces the previous stable value band. This can be explained by the rolling over of the damaged location and also the metallic particles which were introduced. Due to these test results, it can be said that in conclusion, the impedance offers a new way to assess the condition of a bearing. The dependence of the impedance with the film thickness and stability provides information of the lubricating state and the presence of a damage. If you have any questions about this topic, feel free to leave them in the comments below. For further information, or if you are interested, please visit our YouTube channel.